Okay, on this lesson we are going to be adding and classifying polynomials. We'll also be subtracting some polynomials, but the rules for that are going to be the same as adding polynomials. Adding and subtracting are basically the same thing. So let's just start off with adding two polynomials together here. So let's say we've got 3x to the fourth plus 7x squared minus 8 plus another polynomial. We'll make it have the same number of terms here. Let's say we've got 7x to the fourth minus 3x squared plus 4. Okay, so whenever you have a parenthesis, you always look out in front to make sure that you can't simplify. So I'm looking in the front of the parenthesis. I don't see a number here, so technically that would be an invisible 1. So I could multiply in that 1 to everything on the inside, so that way the parentheses would go away. But when I multiply by 1, nothing changes. So it's kind of like the parentheses just disappear. So that one just kind of disappears. And now I'm able to look at that whole thing without worrying about the parentheses. I go to this parenthesis. I do have a plus sign here, so I have to be a little careful. This technically is a plus 1 again. If I were to multiply or distribute into the parentheses, nothing would change. Multiplying a positive 1 times this stuff wouldn't change anything. So again, this parenthesis doesn't do anything to me. Later on, you probably wonder why I'm even doing this. Later on, I'm going to have a minus sign here, or maybe a plus 5 that you have to multiply in or something like that. So I'm looking at these polynomials now, and I need to combine like terms. Adding polynomials, basically when you get to this point, you're just combining like terms. So I'm looking at this, and I've got 3 of these things. Technically they're x to the fourths, but x to the fourth is an unknown. I don't really know what that is, but I have 3 of them. Plus, I don't have any x to the fourths here or here, but I do have some here. So I want to combine those together. So I've got 3 of them plus 7 of them. Total would be 11 of them, x to the fourths. My strategy or my technique is to put a line underneath of the like terms. That way it's easy for me to combine. Next I've got an x squared here. I do want to take a quick scan and make sure I don't have any bigger exponents. I don't. So x squared is the next largest exponent. Are there any other x squareds? Yes, I have a couple of them right here. And so then I need to combine those. So we've got 7x squared minus 3 of them. I have 7, take away 3 is 4. 4 of what, though? X squared. It's not x to the fourths. These are not x to the fourths. I have 4x squareds. So those are gone. What else do I have? I still have a negative 8 right here, and a positive 4 right there that I need to combine. Negative 8 plus 4, it would be minus 4. Can I combine any of these? No, I can't. Even if I tried, they're not like terms, so I can't combine any of those. So this would be my answer when I added those 2 original polynomials together. We'll go over in a minute what I could classify this to be. In fact, let me just kind of write this over on the side. We got 11x to the fourth plus 4x squared minus 4. So in a moment, we'll classify that. Let's do another one here. Let's try and shake it up a little bit, see if we can do something a little different. So if I have 4x to the third plus 7x squared minus 2x plus 1, okay, so there's a polynomial. And then let's subtract 4x squared plus 5x minus 6. Let's say we only have that. Okay, I can't really combine the parentheses yet, the polynomials yet. I need to get rid of the parentheses first. So I look in front of this one. Nothing's being multiplied, so these parentheses are doing nothing. They're not separating this thing from anything, so I'm just going to get rid of that. Okay, what about this parenthesis, though? It has technically a negative 1 in the front, So if I were to distribute this so that way I could get rid of the parentheses, I need to multiply this to everything on the inside. I tell my class, don't be racist. Make sure you multiply it to everything on the inside, not just the ones you like. So that needs to multiply. So that, let's kind of copy this one down. We get 4x to the third plus 7x squared minus 2x plus 1. But this is going to be minus 4x squared minus 5x. And then a negative times a negative is actually a positive. So it's kind of like your mom saying, I need you to come home after school. And you're like, no, Mom, can I go to the mall? And she's like, you can't not go. And so then you're kind of doing some mental stuff, being like, I can't not go. Those cancel each other. So thanks, Mom. I'm going to go ahead and go. Double negative cancels, becomes a positive. All right, now I've got all this. Let's combine like terms. So I start with the largest exponent. That would be x to the third. I don't see any other x to the third, so that just stays. So we've got 4x to the third plus, now I go to the next largest exponent, x squared. 7 of these bad boys minus 4 more of them is 3 of them. I go to the 2x's. I have negative 2 of them here, negative 5 more total would be negative 7x, and then I have the 1 and the 6 would combine to be a positive 7. None of those are like terms, so that's as far as I can go, combining the like terms here. So let's just kind of write that one down as well. We got 4x to the third plus 3x squared minus 7x plus 7. So combining like terms, adding polynomials is basically just combining like terms. Let's talk about classifying real quick. A couple vocab words to talk about. We can classify polynomials by the number of terms and the degree. Okay? So if I were to classify by the number of terms, it just kind of depends how many terms there are. Terms are always separated by addition or subtraction signs. So if I look at this guy, 11x to the fourth plus, so that means that this right here is a term, plus 4x squared, that means that that's a term, minus 4, that would be another term. So this first example we have here has 3 terms in it. This bottom one has 4 terms, I believe. 1, 2, 3, 4 terms in it. So when you're classifying by the number of terms, if there's only one term, it's called a monomial. If we kind of bust into English for a little bit, the prefix mono means one. So there's a few words, like in my class, I asked the class, what are some words that start with mono, the prefix mono? And we'll get some fun answers. You get mononucleosis, the kissing virus. Monopoly, a company that has a domination on the market, or the game Monopoly, where you're trying to be the person to take over all the different board pieces. Monogamy, one spouse. Monochromatic scale, some kids usually come right from art class and they just get done painting with one color. So monochromatic. Oh, a monocle. Yeah, monocle. Monocle's a good one, a one-eyed piece, kind of like the old cartoons or something. We have 2 terms. 2-term would be called a, do you know it? Prefix meaning 2 would be binomial. So the prefix 2, so we can kind of go through a few of those words. Binomial is 2 terms. What are some other words that start with the prefix bi? Binoculars, bicycle, binary. Binary is 2-number system. Bisexual, that usually comes up. There's some giggles going on. Bisexual. Bicep, 2 muscles. Bilingual. Bilingual is another good one. Someone that speaks 2 different languages. We can keep going. 3 terms. So if we've got 3 terms in a polynomial, this polynomial would be called, you probably guessed it, trinomial. Trinomial with the prefix tri meaning 3. Some words that you might think of for tri. What do you got? Trilingual, maybe. Yeah, I'm sure there's tons of people out there that know 3 different languages. Triceratops, dinosaur with 3 horns. Tricycle, 3 wheels. Trisexual, I don't know if that's really a thing. Be careful with that one, probably. So terms, trinomial. Try hard is not one of those, actually. But it was a good effort. 4 terms or more. So if we've got 4 plus terms or 4 or more terms, we're going to use the same word for these ones. So anything that's 4 or more we call a polynomial. So poly means many. If we were to come up with some words that start with the prefix poly, we could come up with polyester. Polyester is a good one. It's composed of many different types of fabric or many different types of string or something that makes it really strong. Polynesians, coming from the Polynesia, meaning many islands. What else? Polygamy, many spouses. Polyamorous, many loves. Let's see, polygon. Polygon's another one. Many sides or many angles. So this is how I can classify by the number of terms. If you want to classify by the degree, this would be the largest. It's basically the largest exponent in each term. Technically, that's not completely true, and I'll cover that in a moment. But for the most part, it's the largest exponent in the term. So if I was looking at this first example here, we have 11x to the 4th plus 4x squared minus 4. So in this first term, the degree of this first term would be a 4th degree. The degree of the second term would be a 2nd degree. The degree of this last term here would actually be a 0 degree because there's no x at all that you can see. It actually has an invisible x to the 0 power right here. So this would be a 0 degree. This entire polynomial altogether has a 4th degree. It's the largest exponent in the entire problem. So that would be a 4th degree, 1, 2, 3, trinomial. So if I was to classify this, this would be a 4th degree trinomial. Okay, how about this other one here? If I was to classify each little term in it before I talk about the whole entire thing, this would be a 3rd degree, 2nd degree, 1st degree, 0 degree. And so there are 1, 2, 3, 4 terms, so it's a polynomial. And if I classified the whole entire thing, I would say the degree and then the word for the term. So this would be the largest exponent is a 3, so a 3rd degree polynomial. 3rd degree polynomial. A couple little vocab words that get used. Coefficient. Coefficient is simply the number in front of the variable. So the coefficient for the x to the 4th term would be an 11. It's the number in front of the variable. Notice it does not include the x, it's just 11. The coefficient for the second term here would be 4. And then the coefficient for this last term would actually be negative 4. So this minus sign gets connected to that 4, so that'd be a negative 4 coefficient. This bottom example would have a coefficient of 4, 3, negative 7, and 7, which leads me to something called a leading coefficient. A leading coefficient is the coefficient that's at the very front of the problem when it's put in the correct order. So these are already in the correct order. So the leading coefficient would just be the coefficient at the very beginning. So 4 would be this bottom one. 11 would be this top one. Now, what do I mean by putting it in the correct order? You should always arrange it based on largest exponent down to the smallest exponent. We're actually almost done with this. So let's say we have 5 minus 8x squared plus 2x minus 3x to the 7th power. Okay, is this written in the correct order? I look at it, this is an x to the 0 power, x to the 2 power. Right away, I already know this is in the wrong order. I need to rearrange it to put it into the correct order. So the largest exponent should be first, so this would be negative 3x to the 7th. Notice that this negative sign comes with it. Minus, this would be next, negative, so I have minus 8x squared. Then I need the 2x to the 1 power, so plus 2x. And then I need the 5x to the 0, which would just be a plus 5 because it was positive. This is the correct order, standard form. And so now I could classify this by the degree and by the number of terms. So this would be what's the largest exponent? It should be at the front, a 7th degree, 1, 2, 3, 4. So a 7th degree polynomial. What is the leading coefficient? Negative 3. So at the beginning, when we were first looking at this, a lot of people would think, oh, the leading coefficient of this is 5. Well, it's in the wrong order. You have to put it in the correct order first, then I'll know what the leading coefficient is. Back here, I could have said, find the biggest exponent. Oh, it's 7, so the leading coefficient would be negative 3. Okay, earlier I mentioned that it's not technically always true that the largest exponent is the degree. And here's kind of an example. Let's say I have x to the 5th power plus x to the 2nd, y to the 4th. Okay. What is the degree of that term right there? Well, it's a 5. What is the degree of this term here? Well, there's 2 exponents there. I have a 2 and a 4. If I add those together, that would make this a 6th degree, which is actually bigger than the 5. So this would be a 6th degree. How many terms? There's 2 terms. This would be a 6th degree binomial. And that's how I could classify this. I hope that helped. Let me know if there's anything I can do for you. Give this channel a subscribe and a like, and we'll see you soon. Thanks, and have a great day.